Good morning, everyone. My name is Ashwin Dube from Mechanical Engineering Department, NIT Polytechnic, Nagpur.
Good morning, everyone. Myself Gressy Shripad from Department of Mechanical Engineering, NIT Polytechnic, Nagpur. Today, we are going to present a technical topic on multi-charging electric vehicle using wind energy. So here we have mentioned here the details of participant, name of the student's email ID, and the contact number. So here we mention a valid identity card of our college, that is NIT Polytechnic, Nagpur. So, content of this seminar, first we will discuss about the introduction of EV or the ideas regarding the EV, idea approach, circuit and the block diagram, actual project and the working model, stimulations and the analysis, what social impact regarding this project, what challenges we have faced and what watch we can do.
So, as the name multi-charging electric vehicle using wind energy, so this is the title of our project. It's a very innovative process for charging the batteries of electric vehicle. Basically, it's a self-charging system which does not require any extra bulk pack or exchanging battery system. As you can see in the picture, a car is running at a constant speed, which will resist the air. This resistance air will run a PWM fans. A set of PWM fans will be mounted in front of the vehicle. So these PWM fans will be connected in series connection for better voltage. And as we know that in parallel connection, we get a better or higher current. So after this connection, it will be connected with the charge controller. The main function or the main purpose why we charge controller is installed is to just manipulate the voltage which is coming from fans and to avoid any type of short circuit in the circuit. In the next lot of the charge controller, the batteries or the lead acid batteries will be connected in series connection. And here the load which will be used is the VLDC motor, that is nothing but brushless direct current motor, which will propel the entire vehicle. So this is what the basic idea is all about.
So next we will discuss about the idea and approach. So first we will see the features of the idea, whatever we are done in this kit. First is the air receives the flow and receives by the fan. Here is the fan will rotate by the airflow and the stainless steel magnet will mounted on the blades of the fans, which gives the smooth and easy rotations to the fan. In which we can see that the battery is getting charged. It means with the series connection of the fans, the battery will get charged.
Now let's move to the another topic, that is circuit diagram or block diagram. It's a very important topic in the entire slide. As I told you, the fans are connected in series connection. A set of or a bunch of fans will be connected in series, which is connected to the charge controller. Charge controller have another and additional function, that is charging feature, which will provide the driver or passengers to charge their mobile phones, or even a light fans is being run through this charging additional features in the cabin system of vehicle. Similarly, the BLDC motor here act as a load which will propel the vehicle from one place to another place. So the main purpose of motor is just to use or to transmit power. So this entire system or circuit system is being designed here. Let's understand this system more easily with the help of block diagram. So as you can see, the here air will act as a receiver which will directly go to the DC to DC booster. The main purpose of booster is just to increase the voltage which we are getting from the PWM fans. As we know that the vehicle will not always move at a constant speed. It will always vary from load to load or conditions. Therefore, a booster will help to increase the voltage. Similarly, a charge controller is installed which will manipulate the voltage, and directly this current or the voltage will go to the charging batteries. After this, the charging batteries will be takes place on BLDC motor. Here act as a propulsion. Act for propulsion, and additional charging system will provided to for the passengers and for the drivers to charge their devices. So this is what the actual circuit and block diagram is all about.
So next we will see about the actual project and working or the design of the vehicle. So here you can see that the actual model photograph, all top view and the side view of the model, the actual design which are going to manufacture. This vehicle is a rear power rear wheel drive, which which means the developed power is given to the rear, which is developed by the BLDC motor. You can see the dimensions of the vehicle: length, width, and height. All the dimensions are given in the mm. The size of the wheels is the 12-inch with the discs of stainless steel. The seating capacity of the vehicle is max to 2 members, means the vehicle can take load capacity of 140 kg. You can see that in the top view, the lead acid battery are mounted of 4 quantity of 12 volt 32H, which is the total of 48 volt. This design is made in the SolidWorks 2016 version, and this vehicle is powered by the batteries and the rear placing of BLDC motor that is of 900 watt.
So now let's come to the very important section again, that is simulation and analysis. So for that, a simulation plays a very important role. So let's move to another, that is simulation. So in this simulator, we have put some input of our vehicles. For example, like you can see in the video also that what type of actually the kilometer which we'll be getting from this, and also the increased battery capacity up to 54 kilometers, similarly 7.5 ah of amperes battery rating, and it will cover at a speed of 25 kilometers with the two load carrying capacity as it is explained by Grace, that is of 140 kgs loading capacity, and energy accumulation in the battery will take place approximately 358 watt hours. So this is all the simulation is done in different wind conditions, in different terrains, in different surface and season wise. So now let's come to the social impact of this project. So first, the driver of e-rickshaw needs to charge his or her vehicle for approximately 6 to 8 hours or even sometime twice a day, which lost their approximately 180 to 200 rupees per day, 6,000 per month, and approximately 72,000, which is a great amount for an e-rickshaw driver. After the development of such type of kits, now battery efficiency can be reached to a good point, and the battery efficiency is reached up to the 33 to 34% here.
So to develop a install or kit in the vehicle, we have to manufacture a vehicle in which we can install a kit. We have to represent an idea for the various executions. We have to go with the process of the documentations legally to install the kit in the vehicle, and we sure that this idea is positive solutions for the e-rickshaws and the e-autos, which regarding less battery backup.
So now let's see about the idea to product challenges, what actually the idea that we have faced while completion of this project is. So first of all, we need to analyze the correct efficiency, practically including all losses. What does it mean? It means that we need to analyze through software or practically that what whether we are achieving the correct correct volume of air at the time or not, or whether we are getting the correct efficiency. So this comes under all the analysis or efficiency. Second, we need to complete the documentation, legal documentation by various automobile societies like ARAI and ICAT approvals. So we need to first go through this process. Then finally, we need to make sure that the spare parts which we have been used in this particular kit can be reasonable and easily available in the market, so that the driver does not need to face any type of problem. So this is what the product challenge is all about. Now let's see, for better clearment of idea, we should watch the video. So the video shows the entire process of how we analyze the problem, how the solution has been find out. So first of all, we analyze what actually the problem with the electric vehicle is, that is the poor battery efficiency. Then we have gone through the various research paper and various technologies that has been in trends in mechanical as well as automobile engineering. And here the market survey plays a very important role, because what actually the scenario of present scenario of market is, we have to first analyze that, and market survey for electric vehicle components for future availability. So this is what all about the all about the trends that we have done in this project. Now let move to the conclusion. Basically what is the conclusion is, now the vehicle will can charge on the go, means the vehicle can charge itself while the running condition, and this energy will be available in every season at every speed. And similarly, the efficiency of the vehicle is increased, as I explained in previous slide, up to 33 to 34%, and the average hitch has been increased up to 8 to 12 kilometers. And finally, we get a consumer satisfaction, that is the driver satisfaction or any owner satisfaction of electric vehicle. So this is what the conclusion of the slide is all about, or the presentation is. So now we are open to the questions. If you have any query or doubt, you may regarding ask this.